Hello guys, if you like this episode, please send me a message. I would love hearing from you. You can also follow us at the Neurophania pod on Instagram. Thank you and enjoy. Hello, my beautiful Neurophaniers. Our guest today, Paul Leenders, is an environmental chemist and independent entrepreneur. In 2009, he formed a consortium of research and development of plasma technology, partnering later with 3 Dutch universities to develop the applications of plasma-activated water. He's a TED Talk speaker of plasma-activated water, nature's answer to chemical pesticides. And he hopes to harness plasma-activated water to fight microbes in hospitals and on farms. Welcome, Paul. Thank you for accepting for being my guest today.
Thank you very much for having me, Amanda.
I'm glad that you accepted, and one of the reasons is the main thing of this podcast is exploring elements, technologies, thoughts, consciousness, and things that are going to take humanity to the next level. And I truly believe plasma is a technology that should be widespread and really honor the applications that it has for ourselves and for better food and so on. So can you tell us a little bit about yourself, your work, and how you became to what you are doing right now?
Yes, okay. Well, I'm Paul Leenders, one of the founders of the company Vital Fluid. The company is working on plasma technology and more specific on equipment of plasma activated water and applications of plasma activated water. Well, I've been an independent entrepreneur since 1995. And in the beginning, I worked in the field of air filtration, and that was high-end air filtration. I've developed filters for aerospace and space industry. For instance, some filters I have developed that are installed in the International Space Station. They're used in glove boxes. Glove boxes are used for to perform chemical experiments by astronauts in the International Space Station. So at that time, I was coming into contact with state-of-the-art technologies, and I have performed the research on the disinfection of air, disinfection of air streams. Mm-hmm. And well, one of the technologies that I came across at that time was plasma technology. It was at that time an emerging technology with promising applications in the field of hygiene and disinfection. So I started first projects in 2009 with a medical university here in the Netherlands to see if this plasma activated air, in this case, could be used as for skin disinfection, to disinfect hands instead of alcohol-based hand rubs. Mm-hmm. And that gave us a good idea of the possibilities of this plasma activated air. And only we had one big problem, because when you create plasma activated air, a lot of ozone and toxic gases can be formed, and you don't want to breathe them in. So that was an obstacle we had to take. And then I came across with another university here in the Netherlands, that is the Technical University of Eindhoven. And a professor there told me about a new phenomenon of plasma activated water. He said, when you treat water with plasma, then the water becomes reactive, and it obtains unique properties. And maybe you can disinfect your hands with that plasma activated water. So we start thinking about that. But yeah, well, if you have water with disinfectant properties, maybe you can also use it for other applications. So mm-hmm. I started a new consortium, and we tested it on agricultural and also some medical applications, skin disinfection and treatment of wounds we looked into. And based on those results, they were very, very promising. I founded the company in 2014, and at that time we were still in the labs of the university in Eindhoven. But at the moment, we are located at the high-tech campus also in Eindhoven. And we have a team of 17 research and development engineers, and which are dedicated on developing applications and equipment for plasma activated water.
Okay, wow, thank you. That's very compelling information. But first, I would like to, because I'm pretty sure many people are not familiar with this. So plasma is the fourth state of matter. Can you develop a little bit more exactly what plasma is and how do you activate water with plasma?
Yeah. Okay, I will try to explain it. Well, we only make use of water, air, and electricity, and we use the electrical energy, to bring normal air, into the plasma phase. And plasma phase is indeed the fourth state of matter. You have solids, you have liquids, you have gases, and then you have the plasma phase. So we use this electrical energy to bring air into the plasma phase, and air consists out of 20% of oxygen and 80% of nitrogen. And by doing that, we create reactive oxygen species and reactive nitrogen species. Mm-hmm. And these reactive oxygen and nitrogen species, they have, well, you can dissolve them very good and very easily into water. They tend to go into the water much more than they would like to stay in the air. So, and by doing that, the water obtains unique properties. The first 15 to 20 minutes, it has disinfecting properties. And when you leave it to rest, what remains is water with some concentration of nitrate. And nitrate is the most important fertilizer for plants and crops to grow. And maybe it sounds a bit scientific what I'm explaining, but the process of activating water with plasma is copied out of nature. It's a biomimicry of a thunderstorm. Yeah. Because when lightning strikes, mm-hmm. and it rains plasma activated water. And when lightning strikes on a water surface, then you have at the impact a lot of plasma activated water. So did you know that more than 10% of all natural bonded nitrogen is caused by lightning? Lightning strikes about 8 million times a day. So, and it is exactly that process of lightning creating above water that we have safely captured in our systems, in our equipment. And this is what the process which we use to activate water. So it's copied out of nature. It's a natural process. Yeah, it is like a going back to nature thing, but made it in a way that can be applicable. And so, and also it is my understanding that the molecules generate like some sort of magnetic field. And according to what you are saying about the reactive oxygen species, which for the people that are listening, the reactive oxygen species are molecules that somehow have like one extra ion, electrical charge, and that electrical charge make it easier to interact with different proteins and different proteins and molecules in our body or in general. So that is one of the reasons why it has some application for disinfecting, but also in medical applications. Before we go to medical, which I might be honest, is the part that I'm more interested about. Can we speak about the agriculture, how this can contribute to, for a cleaner water, and also for underdeveloped communities that they don't have much? How? Mm-hmm. Yes, we can. There are two basic applications of plasma activated water for agriculture. You can imagine that when you treat water with plasma, the water becomes reactive for about 20 minutes. And then when you spray that onto crops, you can treat it from plant diseases, from bacteria, fungi, or viruses. Mm-hmm. And so in that case, you don't need any synthetic chemical pesticides anymore. So you can improve the hygiene of the plant, making it more resilient and making the plant stronger for to fight off these diseases. So that's an interesting application, because you know that those chemical pesticides they pollute the crops they are sprayed on. They pollute our soil and water, and also we eat them because they tend to go in the crops which are grown. So it would be great if you can have an alternative for that. And then the other application that is about the fertilizing properties of this water. Well, at this moment, agriculture uses nitrogen fertilizers to grow crops and to give them extra nutrients. And well, at this moment, where there are 7 billion people on this earth, and with by 2050 we are with 9 billion. So we are increasing, and agricultural production needs to increase too. But by all the nitrogen that is fixated each year for crop production, that's about 140 million tons of nitrogen, which is fixated. They do that with a process called Haber-Bosch. And Haber-Bosch is a completely petrochemical and fossil fuel-based process. This process consumes 5% of the world's natural gas resources each year, and that's around 2% of the world's energy supply. And to produce those 140 million tons of nitrogen, they also produce 200 million tons of CO2. So this equals about 3.2% of the global greenhouse emissions each year. So this is a very polluting way of fertilizing our crops.
Yeah.
And if we didn't have those nitrogen fertilizers, then about 40% of the world population wouldn't have anything to eat. And the bad thing is about 70% of what is applied to crops is lost to leakage in the soil and water. So in our alternative, we just take the nitrogen out of the air, we break it down with plasma, and we dissolve it into feed water, and then with drip irrigation systems, we directly can lead it to the plants. And you can imagine, if you use renewable energies like solar or wind energy, then it's completely circular. Then there's no CO2 output anymore. So those are basically the two agricultural applications we are working on at this moment with our company. And the challenge is to upscale the technology to make this possible.
Yeah, to bring it a little, to ask a little bit, so which companies right now are somehow implementing this, and what do you think would it take to make big governments, or I think that it goes through actually to the companies that start implementing, but it's like time to substitute these things, Monsanto and all these big companies. Hopefully at some point, please.
We hope.
Yeah, I mean, I don't think that we should be worried about, am I eating this tomato and like the pesticides that it has, and I do believe that most of the, it's not belief, there is research, most of the neurodegenerative diseases we have may have some sort of correlation with continuous chronic long-term consumption of all these pesticides, and then 100% has to be something there. And so yes, I mean, long-term, this is a way of striking down the prevalence of many degenerative diseases right now, that they are like an epidemic in some way as well. So it's really important.
Yes, I agree with that. And well, the industry that produces those pesticides, well, they test their chemicals on a case-by-case situation, but they have never tested the effects of when you combine these pesticides on crops or on fruits. There are you can find 10 to 20 different types of pesticides. They have been tested case by case, but the combined effects, nobody knows what that will do.
I mean, it's exactly, and the thing is like the difference is so small that it's like there's never enough evidence, but it's just like a combination. And well, this is another thing. So how do you think this could also be? Oh, something that I was very impressed when I saw the tech talk you did. The plant that the tomato plant that was treated with plasma water rather than just water. We are not even talking water with pesticide. We are just like controlled water versus plasma activated water. The plasma grow the plant growth absolutely beautiful, huge, and it seems that it's just not like a natural fertilizer, but there may be something else there. And I wonder if that takes, if it's just the reactive oxygen species or something else with the magnetic field. I don't know.
Mm-hmm. Yeah, well, that's possible. We know that we dissolve some nitrogen in the water in the form of nitrate, but we also take out oxygen out of the air and also dissolve it into the water. So we put in extra nitrogen and extra oxygen just from the air that surrounds us and put it into the water. And well, the plants, they like that. They tend to grow much better on that. That's true. So, and it's all a natural process. So it's more of a natural fertilizer.
Yeah. I was for preparing for this interview, I was also doing some what is in research in literature, and one of the studies that took more my attention, now maybe moving to the medical part, was that they use this plasma water on leukemia cells lines in vitro, and so basically it was just because if the function were only through reactive oxygen of species, there will be some type of cell deaths, yes, and that's it, which other studies did prove. But they also did a metabolomic study, and there was a clear pattern of different metabolomic pathways that activated or desactivated. So I wonder if that also may have some role if gene expression on the cells. But moving a little bit to the medical applications, I think that you mentioned something about wound healing and also for disinfection of gastroduodenectomies, etc., duodenoscopies. I have seen some uses. Can you explain a little bit about it?
Yeah, we are doing some projects on applications of plasma activated air in the medical field. That's started basically because you need to know if people are working with plasma activated water, you need to be sure that it is safe, that is not dangerous when people come into contact with it. We know it isn't, but you also have to prove it in the lab. So we work with several universities to prove that. And from that point on, we also started to look if you can disinfect your hands with plasma activated water. So you can use it as a hand sanitizer. That's also an interesting application. We are also setting up projects in which plasma activated water is used for wound treatment, infected wounds. We know it can clean wounds very thoroughly. It will break down the pathogens or other dangerous microorganisms which can be present in the wound. And furthermore, we also know, and there's also a lot of scientific research about that the reactive oxygen and reactive nitrogen species, they trigger all kinds of biological processes. For instance, the immune system from people, but also it triggers angiogenese and apoptosis. So the controlled, it promotes and accelerates the healing of wounds. And that is caused by the reactive nitrogen and reactive oxygen species.
Yeah, I mean, reactive oxygen species is one of these double swords in science, in biology, because on one side they lead somehow to apoptosis, cell deaths, but also can have is the one of the main pathways or mechanisms of action for many other diseases. So
but I know that the research on leukemia, on cancer treatment, is they treat cells with plasma activated water, and the cells, the cancer cells, they are very active, and they cannot stand the application with plasma activated water, while normal cells, while healthy cells, they can withstand the treatment of plasma activated water. That's why. And in that direction, they are performing their research.
Yeah, that was very interesting because it seems like the normal cells may have like the mechanism for coping with that, while the plasma, and there is a FDA approved cold plasma gun. It's like a scapegoat. And with this, they have been resecting tumors, and it only affects the cells that are cancerous cells, but not the good ones. And those are like promising medical applications. And
certainly, And just to add to that, we have recently started a project with a university in India, Bangalore in India, on the treatment of burn wounds with plasma activated water, because then you disinfect the wound, and you can also speed up, that's the idea, the healing of the wound. So this project has recently started, and we are now working on a system that will be transported to India. Unfortunately, due to the COVID situation, this will take some weeks longer, because it's not possible to travel at this moment.
Hopefully that, if you, so right now, which companies in Netherlands that are actually applying this technology on their food chain mechanism processing?
Well, we have been we are working with the larger seed companies here in the Netherlands, companies that breed vegetable seeds, because they are faced here with in Europe with new legislation. They cannot use, and they are not allowed to use fungicides on their seeds to treat them with and to get them clean from pathogens and microorganisms. So we have long-term contracts with them to perform research and test on the application of using plasma activated water to get those seeds clean. So the seed industry is working with our equipment, and for the fertilizer application, the biofertilizer. We have been granted an European subsidy to develop this, and actually next week the first machine is going to the research center, to the agricultural research center, and in February of next year we'll be doing some large-scale demonstrations with scaled up systems in the growth of tomatoes, cucumber, and salad.
That's happening next week?
No, next week the first system is going to an agricultural research company, and then we will connect it to their plant feeding system to work on the teething problems, and to get everything right, and to get the correct fertilizer recipe, because that's also very important. And based on that, the information we will get from that, next year, so in February 2021, we will go to the large-scale demonstrations. And we have invited all kinds of companies, horticulture companies, fertilizer companies, and also the seed companies, to come and have a look to our new systems, because the farmer can produce his own bioplasma fertilizer there on the spot, and we hope they will do it with renewable energy, so everything is circular.
Oh, that's so exciting. And I'm just like envisioning my dream house where I can grow my own food and I can have my water activated plasma to grow my food and no need to use all those chemicals, pesticides, which nope. How do you think will be the way for this actually taken to the homes?
To the who? To the you mean to the people at home?
Yeah.
Yeah, well, we hope that if horticulture companies and farmers will use our products, that they will not use those fossil fuel-based fertilizers and synthetic pesticides anymore, but they use sustainable alternatives to grow resilient crops. And that's what this way the farmer can produce much more sustainable products, and the produce that will be eaten by the customers will be less polluting, and we hope more healthy too.
Yeah, you are talking about Netherlands. What about United States? Are you familiar with the United States market?
Yes, we are already in contact. We already have some customers in the United States. They are willing to work with us, and these are one of the companies that will be looking and following our demonstrations, which will start next week and in February, to see what we can do. And we are already working on some commercial contracts to supply them with our systems. And you know, here in the Netherlands, we tend to do everything on a little small scale. When you go to the States, they do it large. They have large service areas. Yeah, and we are going for, of course, that's what we are aiming for the organic market, for organic farming, organic production.
So if the organic, well, I mean, that will take organic market to the next level, and also hopefully make the organic food cheaper and more affordable for everyone, because I guess that one of the reasons why it's so expensive food is the difficulty to grow them. But if we have a technology that somehow, I don't know, 5-fold, 10-fold, how much the production do you think will?
Well, to give an idea, in the beginning of the podcast, I told you about the Haber-Bosch process, which is completely fossil fuel based. This is the way they now produce those synthetic nitrogen fertilizers. This process only the process cost about an energy cost 24 gigajoule per ton fixed nitrogen. At this moment, we are practically at the same level as Haber-Bosch, but we can go to at least about 6.4 gigajoule per ton. So we can always do it more energy efficient than the current fossil fuel based process. We are always more efficient. So our fertilizer will always be cheaper. And the thing is, if you look at the situation here in the Netherlands, how they produce those fertilizers, well, some gas is produced, pumped out of the ground in, let's say, in Kazakhstan, and then they make liquid gas of it. They put it in a big tanker. They transport it over the oceans, over the seas, to the Netherlands, and then it goes into a refinery and big petrochemical installation, and that's there they produce they fixate nitrogen, produce a lot of NOx, which they emit in the air, and also a lot of CO2. And then they have their fertilizers. Then they have to distribute the fertilizers to the farmers, and well, they apply there, and 70% of it is leaching out into the soil and the air. Well, we can produce it on the spot where it's needed. So we take hopefully renewable energy, take the nitrogen out of the air, and just dissolve it into the water on the spot there where it's needed in the concentration that you need. And if you have a closed watering feeding system, then there is no leakage at all. So you can close that loop. Yeah.
Yeah. And is there any research with controls, plasma water versus current fertilizer, chemical and pesticides?
Yeah.
I don't know. I just want to be very positive. Like, is there a chance that even the plasma water pesticide do better? It's not only healthier, more ethical, more affordable, but actually better and more efficient. Is that an option?
Yeah, we see that. Well, we of course, when you go into the professional market of growing vegetables, you have to compare your product with what is state of the art at this moment in agriculture and in horticulture. So we have been comparing our solution, our bioplasma fertilizer, with synthetic fertilizers. Yeah, and we see, and this has been tested by universities. They say, well, this is amazing. From our side, you can say you are at least as good as the what is state of the art at this moment. But we are going to dive into that because we know we think we can be better, because we do not only take the nitrogen, we also take oxygen out of the air, which is also good for the plants. We disinfect the water, so the water is very clean, which is going to the plants. It has all kinds of beneficial properties for plants and crops to grow. They like it a lot. Yeah.
Yeah. I mean, it's exciting times, and as I say, one of the reasons why I'm making this podcast and I'm bringing you is because I am pretty sure there are many technologies that are so good for humanity, and somehow they are still not available. And the reason is because they are cheap, they are healthy, and they are so benign. And I don't know. And I truly believe plasma technology is in this, and I'm truly excited, and not excited, like I'm really curious, and my intuition tells me that it really may have great medical applications as well, since if the research were developed. So in this line, are you familiar with any other technology that you say, this is in the same line of plasma technology that also will really improve the standards of living of humanity?
Yeah. That's a good question. Of course, we have been working and focusing on plasma technology and applications of plasma activated water. So that is really our working field. But I'm sure that there are many other new technologies, for instance, energy storage technologies, which can be a revolution for the way we consume and way we store and produce energy. But the thing is, it can also be a lot cheaper. But the thing is what we experience is difficulty with introducing these new kind of innovations. Is always and in many cases it is the legislation and admission of your product. Because when you look, for instance, at I take, for instance, as example, the pesticides, the chemical pesticides. Well, there is legislation here in Europe and in the Netherlands that is based on those chemical pesticides which have been used for decades and decades and decades. And those chemical pesticides, they are complex organic molecules with metals in it and with dangerous groups in it. They are toxic, and so the legislation is 100% based on how to regulate those kind of substances. So, for instance, they look at what they want to know. What is your active substance in your product? You can say, well, it's molecule A or molecule B, and then they will perform. Then they will follow all the other steps for admission. This is a procedure which takes about 5 to 6 years, and it will cost you a lot of money. Only the big chemical companies like Monsanto and they can afford to do that. When you're a startup and want to introduce these kinds of product, those are difficult steps to take. And if you look at plasma activated water, there is no one active substance, because we create reactive oxygen and reactive nitrogen species, and some of them, they only have a lifetime of, let's say, 1 millisecond or 1 microsecond, and there's an avalanche of reactions taking place. So they don't know how to handle it. They don't know how to regulate those new innovations.
It comes down to this need to control. But if overall they look at the big picture, okay, it's kind of how many times in medicine is like this drug or this thing works. We don't know how it works, but works great. And there are examples that drugs has been used and they don't really know exactly how it works, but it just know that it works. But somehow it goes further and moves forward. So why should be different with other technologies? Like, you don't have to be exactly, honestly, I use my iPhone. I don't know how it works, but I use it. Yep. So why to be so picky? It's kind of like so picky for some things and then for others not, with each overall, the benefit is bigger. And you mentioned something like coming down. Yeah. The moment that they did those legislations in the Netherlands that the companies could not use anymore those XY fertilizers, that's the point where those contracts and those convenios happened. So it seems that it really comes down to legislation, banning of certain things, and automatically, just by necessity, other beautiful technologies and alternatives, because there exist, could just like have a place. And shouldn't be that expensive for you. Should be promoted by the governments, right?
Yes,
should be promoted.
Yes. I totally agree with that.
Right? So
yeah. Well, we are getting more and more supported by our government here in the Netherlands. So that's really a good thing, and they realize that with innovation, it's always the case that it's never the case that create new legislation so that innovations can be implemented. No, you first need a new innovation, and then the legislation, the laws can be changed to approve it in a more efficient and maybe more cheaper way.
Yeah, I was very impressed that the Netherlands did those bans, and that's really huge steps.
Yeah. And of course, on the other side, we here in Europe, they have what they call they call it a farm to fork strategy. They want to reduce the use of synthetic and chemical pesticides by 2030 by 50%.
Wow.
Yeah, and they want to decrease inefficient use of those fertilizers, which leak out to the soil and the bottom, and the air. They want to decrease that leakage, that fertilizer loss, also with 50% by 2030. So,
I mean,
that's good for us. Sorry.
Those are encouraging news.
Yeah. That's very encouraging, and we hope that we can benefit from that, because this is what we are working on with our technology to achieve that.
Yeah, I mean, I believe this is an amazing job, and really because of the large impact. It's all about it has can have such a huge impact on health long term for people, but it really comes down to the foundations, and this is so important. So thank you.
Okay.
And so I think that I have covered all the questions that I was really curious about, that I wanted to learn. But of course, would you like to tell us if people would like to get in contact with you, how they can do it, and also maybe add something that you feel I didn't address?
Well, if someone would like to contact me, maybe it's the best to do that through the company. The company name is Vital Fluid, which is located in the Netherlands. And maybe if they cannot find my name or the company's name, then they can do it to you, Amanda.
Yeah, I will definitely leave the links. The links and the information will be added on my webpage for the podcast. So definitely.
All right. Okay. That's good. Yeah.
Okay, so thank you so much for taking the time for being here with me today. And I will see you next time.
Okay then, Amanda, thank you for, it was very nice being your guest. Thank you very much.
Thank you.
Okay.
Okay, no, here.
Yeah.